As an Electricity and Gas Measurement Canada inspector, your job is to inspect and verify metering installations and devices under the Electricity and Gas Inspection Act. By properly conducting these inspections, you are protecting the integrity of Canada's trade measuring system, contributing to consumer and trader confidence across the country. The most vital part of every inspection is safety. In certain situations, following the proper safety precautions during your inspection can mean the difference between life and death. The purpose of this video is to demonstrate how to properly and safely inspect electricity metering installations when they're located near exposed live electrical equipment or circuits. We will also cover the personal protective equipment, or PPE, that must be worn during these inspections, when and how it is to be worn, and the limits of approach that must be followed. Additionally, at the end of the video, we will examine how to test electricity meters safely in a meter shop. This presentation is divided into chapters. You can view the entire presentation at once, or you can view it chapter by chapter. You can always return to a previous chapter or jump ahead in the presentation. Simply return to the main menu to make your choice. The material in this presentation is contained in your Electricity and Gas Inspection Procedures Manual, which is always an important reference tool to have on hand. Only qualified Measurement Canada inspectors can inspect or test metering installations. If you are an employee who performs inspections of electrical metering installations involving electrical hazards, you must be a qualified person. According to CSA Standard Z-462, a qualified person is someone who has training, knowledge, and experience in the construction and operation of the equipment or specific work method, has been trained to recognize and avoid electrical hazards that might be present with respect to that equipment or inspection method, is familiar with the proper use of the applicable special precautionary techniques and personal protective equipment or PPE, including arc flash, insulating and shielding materials, and insulating tools and test equipment. It is important to note that Measurement Canada inspectors are not authorized to work on live metering installations. Measurement Canada inspectors are authorized only to test and inspect energized metering installations. Working on equipment is only to be performed when the equipment is in a de-energized state. As a Measurement Canada inspector, you have a responsibility to be mindful of the following general safety practices when working around exposed electrical equipment. 1. Conductive articles of jewelry and clothing, such as watch bands, bracelets, rings, keychains, necklaces, metallized aprons, cloth with conductive thread, metal headgear, and unrestrained metal frame glasses shall not be worn where they present an electrical contact hazard, unless they have been rendered non-conductive by covering, wrapping, or other insulating means. If the insulating capabilities of your personal protective equipment may be subject to damage during use, then the insulating material must be protected by a non-conductive outer covering like leather. 2. Employees shall be alert and avoid distractions like cell phones and potential loud noises at all times. Inspectors shall not be permitted to work in areas containing live parts or other electrical hazards while their alertness is recognizably impaired due to illness, fatigue, or other reasons. 3. Inattention to the task at hand and horseplay are not acceptable practices. 4. Employees shall not enter spaces containing live parts without adequate illumination. 5. Protective shields, protective barriers, or insulating materials shall be provided by the contractor. 6. Employees shall use insulated equipment and tools as appropriate. All tools and equipment shall be checked for safety, applicability, and appropriate rating prior to usage. Defective, worn, or damaged equipment shall be tagged and not used until repaired. 7. General hazards shall be avoided, such as foot, leg, knee, back, eye, or neck injury caused by a continuous or repetitive motion. For example, standing for a prolonged period of time. Inspectors shall avoid these injuries and other hazards through varying their type of inspection. 8. Other specific identified hazards are voltage and current. Each of these, in conjunction with resistance, has varied effects on the human body, depending on the points of contact and the duration of contact. Secondary incidents can also occur. For example, an electric shock could lead to a fall, resulting in a concussion or other injury. 9. Employees shall ensure that non-conductive clipboards and writing tools are used. 10. Employees shall ensure that the general work area is clean and free of obstructions that could interfere with testing operations or create a hazard. 11. Employees inspecting energized electrical equipment shall use knowledge, planning, and safe operation techniques to ensure a safe area of work. 12. Restrain long hair and ensure that any clothing that could become entangled in equipment is secured. As a Measurement Canada inspector, you are under no obligation to conduct work at a site that you conclude to be unsafe. In fact, if the safety of a site is under question for any reason, you should notify the appropriate Measurement Canada personnel as soon as possible. The human body functions on between 10 and 100 millivolts. This is just a fraction of that delivered from Measurement Canada low-voltage work. An electrical shock occurs when electric current passes through your body. This surge of electricity can interrupt the normal operation of the human electrical system. If an electric current passes across the heart or brain, you can be electrocuted or suffer serious effects. The resistance of skin transforms electrical energy into heat, which produces burns around the entrance point. Current flows through the body from the entrance point and exits where the body is closest to the ground. An electrical arc can occur if a conductive object gets too close to a high current source. Arc flash temperatures are the highest temperatures known to occur on Earth and can be up to 35,000 degrees Fahrenheit, or 4 times the surface temperature of the sun. Electricity can arc through the air even if you are not directly touching the source. An electrical arc is often drawn to highly conductive sources, such as perspiration areas, and will enter the body at these points. The closer the worker is to the arc source, the greater the risk. When an arc occurs, there is a rapid expansion of air, and this strong air pressure can create an arc blast, which is usually forced to the open side of an enclosure. The noise level from an arc blast can be up to 140 decibels, which can seriously damage your hearing. Materials are often vaporized during an arc blast, causing droplets of molten metal or shrapnel to spray outward. Contact with this shower may cause your clothing to catch fire. Electric shocks and arc blasts can cause affected workers to fall from aerial equipment or drop tools and equipment. Be aware of these added hazards when conducting or assisting with overhead electrical work. The 3 main risk factors associated with arc blasts are power, or the amount of energy at the arc, the distance of the worker to the arc, and time, or the duration of the worker's exposure to the arc. Contact with live circuits or working close enough to the energized part to generate an arc can have serious consequences. A minimum of Category 2 arc flash clothing is required when inspecting all energized electrical installations. Follow all posted incident energy labels or consult with on-site personnel to determine if Category 3 AF PPE is required. Category 3 arc flash PPE is recommended if an employee is taking voltage readings in a fuse panel of a 3-phase 3-wire 600-volt delta metering installation. Follow all posted incident energy labels and consult with on-site personnel to determine if Category 2 PPE is permitted. A minimum of Category 2 arc flash clothing is required for a typical multiple customer metering system or MCMS installation. Follow all posted incident energy labels and consult with on-site personnel to determine if Category 3 PPE is required. Measurement Canada inspectors are not permitted to conduct inspections on high-voltage type metering services. You should know how to recognize and identify these types of installations in order to call in the electrical line crew. In some cases, the utility may require Category 4 arc flash clothing regardless of Measurement Canada standards. And if that is the case, the Measurement Canada inspector must seek an alternate means of conducting the installation inspection, confirming the necessary end result while ensuring his personal safety. Measurement Canada inspectors are provided with HRC-3 PPE for situations where the arc flash levels do not exceed 25 calories per squared centimeter. Follow all posted incident energy labels and consult with on-site personnel to determine the category of arc flash clothing required for the specific site. If it exceeds Category 3, remain well clear of the outer AF protection zone. Measurement Canada employees are qualified up to 750 volts. Based on the Canadian Electrical Code, high voltage is above 750 volts, low voltage is between 31 to 750 volts. The minimum acceptable approach distance for metering installations with a voltage of 751 to 90,000 volts is 4.5 meters. For installations with a voltage of 90,000 to 400,000 volts, the minimum acceptable approach distance is 9 meters. Remember, Measurement Canada inspectors are only authorized and trained to test or inspect metering installations and are not authorized to perform work or repairs on metering installations if they are energized. Measurement Canada inspectors are typically not equipped with the appropriate arc flash rated clothing to be protected from the incident energy created from an arc flash. If work has to take place on the metering installation or line maintainers are performing work at the site, the inspector has to be aware of their limits of approach and move well back of the flash protective boundary. The following table outlines the limits of approach boundaries to energized electrical conductors or circuit parts for shock protection. All Measurement Canada inspectors should be familiar with the personal protective equipment required to safely perform an inspection. Special purpose CSA-approved safety-toed footwear is provided to Measurement Canada employees who are exposed to the following. For dangerous liquids, footwear either constructed of impermeable materials or specially treated to protect the wearer's feet from contact with dangerous or corrosive liquids or other dangerous substances, or in situations where the feet may be immersed in such liquid. For explosive hazards, footwear made with non-sparking or non-conducting materials, except metal box toe, for use by workers subject to explosion or electrical hazards. For electrical hazards, footwear approved by CSA for impact with a minimum rating of Class 1, showing a green tag or green triangle, and displaying the omega symbol on the tag. For temperature extremes, thermo-insulated footwear for extreme cold, a wind chill of more than 1,600 watts per square meter, for example. In terms of safety headgear, Measurement Canada inspectors are required to wear A. Class E protection hard hats that meet impact and penetration requirements. Safety headgear must also have an appropriate non-conductive rating and must meet the requirements of CSA's standard Z94.1-M1977. B. Chin straps or other effective means of retention must be used on safety headgear when workers are climbing or working from a height exceeding 3 meters, or are exposed to high winds or other conditions that may cause loss of the headgear. C. Winter foam liners with flame retardant material as required by weather conditions. When inspecting metering installations, limits of exposure or the noise exposure level must not exceed 87 dBA. Hearing protection must meet the requirements set out in CSA Standard Z94.2-M1984. They may be either pre-molded or moldable. Earplugs are sold as disposable products or reusable plugs. Custom molded earplugs are also available. Measurement Canada also supplies ear muffs, which consist of sound attenuating material, soft ear cushions that fit around the ear, and hard outer cups held together by a headband. The employer shall provide face shields and balaclavas for eye or face protection, including prescription safety eyewear that meets the standards set out in CSA Standard Z94.3-M1982, Industrial Eye and Face Protectors. The face shields for electricity meter installation inspection work, designed to prevent arc flash injury, shall be rated to a minimum of 8 calories per squared centimeter and meet the requirements of CSA Z94.3.02 and CAN-CGSB-155.20-2000. Balaclavas shall have a minimum rating of 23 calories per squared centimeter, meeting ASTM Standard 1506. The balaclava worn under the face shield will provide increased arc flash protection up to the HCR 3 level. Loose clothing, long hair, and dangling accessories like neckties or jewelry that could be hazardous to the health or safety of an employee in a workplace shall not be worn unless they are tied, covered, or otherwise secured so as to prevent the hazard. When wearing electrically rated gloves, jewelry on fingers and wrists is forbidden. Flame-resistant clothing shall meet CSA Z462-12 and CAN-CGSB-155.20-2000 standards. In rare circumstances, you may be required to wear a respirator or self-contained breathing unit. Should this be the case, please contact your manager for further direction as to required training ahead of your use of such equipment. A fall protection harness is required when working from an unguarded structure, ladder, or vehicle at a height of more than 2.4 meters above the nearest permanent level. High visibility safety apparel, or HVSA, is worn to alert drivers and other vehicle operators of a worker's presence, especially in low light and dark conditions, or when part or all of the wearer's body could be obscured by mobile equipment operating in the area. Consult the CSA Standard Z96-09, High Visibility Safety Apparel, and the related guideline CSA Z96.1 on selection, use, and care of high visibility safety apparel. If flame-resistant or arc flash protective clothing is to be worn in the same area where HVSA is required, and it is already equipped to Standard Z96-09, it is considered to be compliant. The following table illustrates which articles of safety clothing are required for each hazard or risk category, as well as the arc flash rating when wearing each piece of clothing or when combining pieces of clothing. Hazard Risk Category or HRC 2 rated clothing shall be provided to all electricity inspectors who are required to wear arc flash protective clothing in compliance with the voluntary CSA Z462-12 Workplace Electrical Safety Standard rating for the applicable work, which is typically 8 calories per squared centimeter. This clothing will include HRC 2 rated pants, shirts, and jackets or coveralls. Measurement Canada inspectors shall be provided with HRC 2 rated coveralls. Employees required to perform measurements on electricity metering equipment or witness utility personnel taking measurements that could result in an arc flash level up to 24 calories per squared centimeter, or Category 3, shall be provided with an additional pair of Category 2 coveralls. This additional pair of coveralls shall be worn over the first layer of HRC 2 rated clothing to achieve Category 3 level protection. Clothing made of natural fibers like cotton, silk, or wool must be worn underneath the outer arc flash protective clothing to minimize skin burn damage if an arc flash occurs. Nomex or equivalent coveralls will be provided to employees working in potentially flammable environments. The material must be Type 3A. A Nomex or equivalent parka will be provided to all inspectors for use in cold environments. Electrical installations should never be inspected in the rain. It's important to note that while all ARC-rated or AR clothing is flame-resistant or FR, not all flame-resistant clothing has been ARC-rated. All Measurement Canada ARC-rated PPE purchased and worn for electricity metering installation inspections shall be flame-resistant or FR. Flame-resistant PPE helps protect electrical inspectors from receiving severe burns when exposed to a flame, and is also self-extinguishing when the source of the flame is removed. Inspectors should always be aware of the AF approach boundaries and ensure they do not proceed past the limited zone when performing their inspection procedures. The first layer of clothing next to your skin must be cotton, wool, or another natural fiber. Never wear synthetic materials such as acetate, nylon, polyester, or rayon alone or combined with cotton where arc flash risk exists, because these materials will melt to your skin. For any electrical installation inspection, voltage-rated rubber gloves are required to meet Class 0 and must be used in conjunction with leather gloves to protect the rubber. Ensure that rubber gloves have not been excessively worn and are free of pinholes, cuts and abrasions, and are free of debris that could damage the gloves. Before wearing rubber gloves, inspect them visually. Ensure they are within the expiry and inspection dates, and perform a field leak test before daily use. The air leak test is performed by holding the glove cuff with your hands and forefingers and twirling it around quickly to fill it with air. Squeeze the glove, then look and listen for escaping air. Examine your gloves closely for embedded foreign materials or surface contaminants that could impact their performance in any way. Ensure that rubber insulating gloves are tested with a dielectric test at least once every 6 months, and destroy any gloves that are defective. Always wear gloves right side out, with the serial number and size on the outside. Gloves should be stored in a protective case, typically a canvas bag, to protect them from sharp or pointed tools that may puncture them and from UV light. PPE will always be required when the potential for arc flash exists. However, it's important to remember that PPE is at the bottom of the control measure hierarchy, and other control measures, like elimination, administrative, and manufacturing controls, should always be considered first. You can minimize risks by complementing PPE with safe work practices, like the one-hand rule. When connecting and disconnecting test equipment, use only one hand to take the body outside of the flash protection boundary. Stand to the side of the metering equipment, and make sure to inform others of your actions in advance. Controls like plexiglass covers are used to minimize the risk of accidental contact with energized parts. All test equipment purchased by Measurement Canada and used for electricity metering installation inspection work is rated for the application for which it is used, usually Category 3 minimum, is robust and constructed for use in entry-level protection. Make sure to check insulated tools and equipment for damage before use, and ensure they are suitable for the task. The shock and arc flash analysis will provide the information required to develop an arc flash and shock hazard label. The Canadian Electrical Code requires that electrical equipment likely to require examination, adjustment, servicing, or maintenance while energized shall be field marked to warn persons of potential electric shock and arc flash hazards. Be aware that sometimes equipment markings may be incorrect or missing. When entering a work site, it is always imperative to assess the safety of the installation site prior to proceeding into the immediate work area. Safety is everyone's concern and responsibility, and must always be assessed. A work site can be an electrical room, metering cabinet, a plant, or a construction site. Regardless of the location, The inspector must always ask the following 4 questions when assessing the worksite. 1. Does a hazard exist? Some examples of hazards to look for are water on the floor around metering or electrical equipment, poor lighting in an electrical room, limited space because the room is used as storage, potential for falling debris when cabinet doors are opened, other moving machinery or equipment. It's also important to consider whether there is access to high voltage. This is a 600-volt meter. The metering installation is outside, up a pole, near traffic, a school, or a farm. The air quality is safe, and whether there is a possibility of gas leaks, ammonia leaks, or carbon monoxide. This is a confined space requiring a special breathing apparatus or gas detectors, in which case an inspector is not qualified to enter. 2. Where is the hazard or danger? Is the hazard or danger concentrated in one specific area, or can it be found elsewhere at the worksite? For example, is there water on the floor in more than one location within the electrical room? Is there moving machinery on both sides of the metering installation? 3. What is the hazard or danger and its risk? Take a good look at each hazard identified. Then make an assessment of the potential risk each hazard possesses that could result in an accident if steps are not taken to minimize the risk. If the assessment determines the risk to be high and it cannot be eliminated or minimized, discontinue the inspection. Remember that each inspector must make their own assessment based on their knowledge, experience, and comfort level with each situation before making any decision on whether or not to proceed. If you are unsure or not comfortable with the situation, it is recommended not to proceed with the inspection. 4. What steps can be taken to eliminate or minimize the hazard? Each inspection area must have the hazard elimination determined on a case-by-case basis, considering the possibilities of material available to cover a wet area on the floor, removal of material or equipment obstructing metering equipment, requesting that the owner shut equipment down during the inspection, establishing and using limits of approach for exposed live wiring as sufficient, tailboard discussion with the utility representative before entering the site, the presence of a utility representative who is appropriately trained and qualified and can take the required voltage measurements, a utility representative who can remove the meter if required. If specific questions or concerns arise, contact your technical specialist or regional manager in charge of workplace safety. Static testing an electrical metering installation provides Measurement Canada inspectors with a step-by-step process that will ensure they are completely aware of their surroundings. It also helps inspectors identify any possible safety issues related with the electrical service or equipment, and to verify that the service is within their qualifications and rated under 750 volts. First, make sure to locate and identify all components and either record or verify all necessary information of the metering service. A. Locate the main switch of the incoming service, and, if different, also locate the main switch of the service being verified. B. Identify the following where possible and applicable: line and load side of main switch or switches, main service grounding wire, any splitter boxes, CT/PT cabinet or switchgear, metering cabinet, any applicable wiring conduit. C. Record or verify service and metering information such as service type, service ratings for voltage and current, meter info, numbers, type, multiplier, and ratings, CT/PT info, numbers, type, and ratios, billing multiplier. The billing multiplier is equal to CT ratio times PT ratio times meter multiplier times circuit multiplier. Next, identify the appropriate standard drawing. Once the correct standard drawing is identified, visually verify that A. The installation is using the correct color code for all associated voltage, current, ground, and neutral connections, and B. All associated voltage, current, ground, and neutral wires are correctly connected as per standard drawing. Finally, Complete all remaining non-measurement data on your worksheets. Prior to performing any dynamic tests or voltage measurements, always 1. Test your rubber gloves. 2. Ensure all of your equipment is in good working condition. 3. Check all connections for loose ends or damage. 4. Ensure all test leads are properly fused. Measurement Canada inspectors are not to inspect installations alone. Rather, they are expected to use the buddy system approach. Ensure you and your partner are both utilizing proper safety equipment and that your partner is suitably trained in the electricity field for sub-metering or multi-customer metering systems. Before taking any voltage measurements, visually re-verify the voltage rating of the service to be measured. Also, re-establish or confirm the line and load sides of switches from which measurements will be taken. You should always take voltage measurements on the load side of the main switch. Once the location of where to take the voltage measurement is determined, as well as what range of voltages you expect to actually measure based on service type and rating, ensure, prior to taking any measurement, that you're 1. Standing on firm, dry footing, and 2. You are stabilized with feet spaced shoulder-width apart. In the case of low cabinets or switch gears, kneel on one leg with the other foot forward to stabilize your position. Kneeling on one leg can only be done safely if an insulated pad is used under the knee. Otherwise, it defeats the insulation of the safety footwear. Remember never to lean forward into cabinets or switch gears. When taking primary voltage measurements, measure neutral to ground first in order to establish these points are one and the same. An electronic voltmeter should provide a reading of less than 0.2 volts if this is the case. Measure phase to neutral ground voltages. Always connect your voltmeter to the neutral ground point first, then to the phase. Next, measure phase to phase or line to line voltages. Any cabinet doors in which exposed live bus bars exist should be closed immediately after measurements are taken. If some or all voltages cannot be taken in a safe manner, then proceed to the steps outlined in the next section. Follow these steps to connect the analyzer in a safe manner. 1. Verify that all connections on the analyzer are tight and have not been damaged during transportation of the device. 2. Ensure that all voltage and current leads are not tangled together in such a manner that may cause safety concerns. 3. With the analyzer turned on, set it to measure secondary voltages. Make ground connections first, then connect to one phase at a time, ensuring that the analyzer is seeing the correct voltage and verifying a proper connection. 4. Set the analyzer to measure secondary currents. Prior to opening the test switch on the test block, visually verify the integrity of the switch to ensure that good connections exist for current bypass. Open the switch and connect the appropriate current probe, while observing the current indicator on the analyzer to confirm a good connection has been made. Be sure to observe the correct polarity of the current probe prior to making the connection. If no current reading is observed, remove the probe and recheck the equipment's setup, usage, and connections. Most analyzers used by Measurement Canada inspectors now permit simultaneous measurement of primary and secondary currents, and some display the ratio directly. With the Fluke and Hioki analyzers, you have to do the calculation, but both primary and secondary currents can be measured and displayed simultaneously. The following is the procedure for determining current transformation ratios. 1. Establish the current range in which you are expecting to measure for the service. This can be done by using the primary rating of the current transformers, but a common practice is to take the highest secondary current being measured by the analyzer, then multiply it by the ratio of the CTs to determine existing load at the time of testing. 2. Once established, Using a suitable ammeter that is capable and set to measure current in the expected range, check the accuracy of the current transformer ratios. This is usually accomplished by reading both primary and secondary current simultaneously. Primary current is obtained via the ammeter. Secondary current is obtained via a circuit analyzer. Record the results on a worksheet. In some instances, the secondary current is not available at the test block, in which case a second ammeter will be required to measure the secondary current at a safe location between the CT and the meter. It's important to note that frequently, for reasons of safety, this testing cannot be completed. This is a prime example of where common sense must prevail at all times. The message here is to proceed with the utmost caution. If you are in any doubt as to the safety of making these connections, then don't do it. The aim of the CT ratio test is not to check the accuracy of the CT, but only to ensure that a CT marked as 600:5 is not a 400:5 or 800:5, for example. At this point, you will take phase readings as stipulated by the worksheet, although some analyzers record the phase angles and display the phase relationship directly. These readings are to be compared to the instantaneous values recorded by the meters at the time of testing. Today's analyzers can usually yield results within plus or minus 1.0%, even under fluctuating load conditions. When completing your inspection, 1. Ensure that all relevant information has been noted and documented on the worksheets. 2. Indicate the rating of the installation as found at the site. Verification of the billing multiplier when the inspector returns back to the utility billing office may require this rating to change, should a problem be discovered with the billing multiplier. 3. Apply a verification sticker to the metering cabinet that includes the initials of the inspector and date for future reference. 4. Before leaving the site, carefully remove any equipment still connected to the metering circuit. Close all connections as required, and visually verify that all meters are functioning correctly. It is important for each inspector to understand that the information provided in the safety video, specifically the safety by sequence procedures, cannot be learned in isolation from the in-lab and in-field training provided for each type of service. Inspectors will need to incorporate these safety procedures into all aspects of their training in order to successfully establish a standard safety approach for any inspection conducted. When working with live equipment in a meter shop, the following procedures should be employed. 1. Only qualified employees or persons working under the direct supervision of a qualified Measurement Canada employee shall be permitted to work on or near electrical equipment. 2. Personal protective equipment shall be selected, inspected, and used appropriately, as per Measurement Canada procedures. 3. All tools and equipment shall be checked for safety, applicability, and appropriate rating prior to usage. Defective, worn, or damaged equipment shall be tagged and not used until repaired. 4. Qualified employees shall check to see that the test console and associated devices are wired correctly with no loose wire connections prior to energizing the equipment. 5. Qualified employees shall familiarize themselves with safe operation of the test console and know all safe methods of deactivation. 6. Qualified employees shall ensure that variacs and rheostats on the test console are set to 0 prior to energization or changing of loads. 7. When conducting extended testing, in which equipment will be energized for periods of time greater than normal testing, and a qualified employee will not be continuously attending, the area must be prominently marked to display the danger presented and who is in charge of the operation at hand. Entrances shall also be marked to warn anyone entering the area that appropriate PPE and training is required for entrance into the area. An employee must periodically check connected equipment for anomalies for personnel safety test progression, and equipment preservation. When conducting inspections around live electrical equipment or circuits, wearing the appropriate PPE and following the proper safety procedures is critical to your own health and well-being. There's no excuse not to be vigilant about these rules and regulations. They might just save your life.